so this inverted tank, the base radius, so that length right there is 2 meters. Okay. The height is 4 meters. Okay, and water is being pumped in here. And do you agree that this is going to be a dV over dt? Water is volume, right? dV over dt is 2 meter cubed over minute. Okay. At what rate is the water level rising when the water is 3 meters deep? What is it asking for? That's right. It's asking for dH over dt. What is that? So find this when h is 3 meters. Okay. So there's two dimensions you have to consider. There's actual volume of the water that's climbing up, so it's going up, right, as the water is being poured in, and the actual dimension of the entire tank. Now this is fixed. This is 2, this is 4, but this radius here, let's call it r, is not fixed. It's changing as the water is being poured in, and this height is also constantly changing as the water is being poured in. Let me give you the formula for cone. Do you guys know by any chance? Yeah, it's 1/3 of the cylinder. 1/3 pi r squared times height. Okay. I want to find dH over dt. There is h there. Okay, there is h. But there's r too. H, R, V, they are all changing. Right? They're all changing as time changes. This is not good, right? Because we don't know what dr over dt is. Okay. Is there a relationship between r and h in this diagram? So, look, see the orange triangle is always going to be similar, no matter where the water is, at what level. R over h would have to be proportional to 2/4. So Jim was right. Jim said the height is always double radius. I said always. He said hopefully. So that's what made it a little bit weak statement, right? But it is true. Height is double of r. Okay. If you cross multiply and reduce. Okay. So I want this to be all in terms of h. So I'm going to replace this r with half of h. Like that. Okay, so because of this relationship between r and h, this initial volume equation turned into this one now. Now let's differentiate both volume and h respect to time. So we get dV over dt 1/12 pi 3h squared dH over dt. We're almost done. This is given to be 2. H is given to be 3. Okay, so dH over dt is going to be 8/9 pi. Okay, and this is all in what unit? It's meters per minute, right? Alright. Okay, so you have to have a concluding statement. Therefore, the water level is rising at, let's write it out, 9 pi meters per minute.